Okay, geometry, welcome back. For some didn't save onto YouTube, so here we go, 2.0. Classifying polygons. This is a nice, short, sweet video, and like I said, we already did this video, so that means everything is already filled out. I really didn't want to waste paper, but in any case, I can identify and classify polygons. I can find the lengths and sides of polygons, particularly if they are regular polygons. That's a vocab word that you want to pay attention to. So here we go, the warm-ups. And I want you to just kind of pay attention to one at a time. I'll cover those up. So we want to solve for x here. I want to get x by itself, so I'm going to add 8. So if you add 8 right there and right there, those will cancel. You have negative 19x on the right side, and 11 plus 8 is 19. Then divide both sides by negative 19. You're going to get negative 1. So apparently when I did these, I skipped a lot of steps. How about part B? Now, I have two variables on the same side of the equal sign. So when you have that, you need to combine them first. 5n and negative 4n will be 1n. And I know some of you aren't comfortable with the variable by itself, so you could put a 1 there first. We want n by itself. Get rid of that 5. These cancel. 1n is going to equal 2. And again, if you want, you can also write it like this. The last one, it's a little bit of a glare. Here we go. Combine like terms. 2 and 8 is 10. This is a bad glare. No, that's worse. Okay, we'll figure it out. So I have 3x plus 10 equals 2x. And again, now I have variables on both sides of the equation. So I'm going to move that smaller one over. We're going to subtract 2x on both sides. You have a negative 5 on the right side by itself. 3x minus 2x is 1x plus 10. Subtract 10 on both sides. Negative 5, negative 10 equals negative 15. So far, so good? Alright, here we go. A polygon, I already highlighted it for you, so you might want to break out that pink highlighter, pause it if you need to, is a closed figure. Okay, closed meaning all the sides will connect, so there's corners. With the following properties. It is formed by 3 or more line segments called sides. Each side exactly intersects 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. Each endpoint of a side is called a vertex of a polygon. Polygon can be named by listing the vertices in consecutive order. So for instance, if you see this shape right here, you can call it A, B, C, D, E, F, or C, D, E, F, A, B, but it has to go in an order. So you're either going to go clockwise, or that would be clockwise, or counterclockwise, your choice. A polygon is convex if no line contains a side of the polygon. If no line that contains a side of the polygon contains a point in the interior of the polygon. So basically, if this point was in here and it connected, it would be an interior point. Otherwise, it's concave. So here we go. Now, I named those hexagon up here. Here, there's, lots of different varieties, probably 6. Here we go. Tell whether the polygon is convex or concave. So if it caves in right here, this point and this point make it concave. This one's concave because of this one and this one. This one's concave. Again, if that point was out here, it would bow out and it would be convex. The rest of these are convex. So far, so good? Told you it was fast. Okay, classifying polygons. This is a nice little pretty chart. Of course, yours was in black and white. My original video was in black and white, or grayscale you can call it. But here we go. These are actually all regular polygons. Well, not all of them. Not this one. But because regular means all 3 sides will be the same and all your angles. So this has 3 sides, 3 angles, 3 vertices. No diagonals. I'll explain what that means in a second. That'll come important later. A quadrilateral. So we have 4 sides. This could be, your square, your rectangle, rhombus, etc. But in this case, it's a trapezoid. 4 sides, 4 angles, 4 vertices, 2 diagonals. So a diagonal could be this way or this way. Okay, so how many ways can you make a triangle, I guess, out of them? A pentagon, how many diagonals? That's what I want to focus on. You can have a diagonal like this. 1, 2, 3, 4, 5. That one's already existing. So 5. And a hexagon. It's kind of hard to do it with these dark colors. Heptagon, the reason why I highlighted that one, is also called a septagon, but heptagon is what I'll use more often. I'm just used to using that. Your octagon, your nonagon. I don't think I've ever heard anyone call it a novagon. Decagon, dodecagon, and anything beyond that is usually an n-gon, like a 13-sided figure, 13-gon, etc. Alright, so some other terms. The term n-gon, where n is the number of sides of a polygon, can also be used to name the polygon. So if you forget the name of a heptagon, which is 7 sides, you can call it a 7-gon if you choose. In an equilateral polygon, all sides are congruent. In an equal angular polygon, all interior angles are congruent. And then a regular one, this is my important one, let's actually put a star there. A regular polygon is a convex polygon that is both equilateral and equal angular. So, because this is the one that you can do a lot of stuff with, especially hexagons. That's a big ACT question coming up. This table is shaped like a regular pentagon, so maybe it's like a card table. The expression shown represents the sides, so you have to put this on there and this on there, okay? Those are the side lengths. Now, if this is regular, that's important, that means this is the same as that. So if you'll notice, 5x minus 3 is equal to 7x minus 13. Set those equal to each other. Subtract 5x on both sides. You get negative 3 on the left side. On the right, 2x minus 13. Add 13. 2x is equal to 10, so x is 5. So x stands for 5. I don't have it in any unit here, so 5 units. Now find out length of each side. They need to be the same, but if you substitute 5 in, 5 times 5 is 25, then take away 3, you get 22. 7 times 5 is 35, minus 13, you get 22. So that does work out. Always check your work. So each side length is 22. Well, I have 5 sides. Remember, they're asking us for the length of a side and the perimeter. Take 5 times 22, you get 110 units. All right. I know that I have the assignment written on this one at the bottom, but it's actually 3 pages for your packet. So here's your assignment, and the Common Core standards are on the next page. Everyone, have a nice evening, and stay dry. We have thunderstorms we've been through.